All, my name is Gulshan working as an assistant professor, AI and DS department, SNS College of Engineering. So now in this we are going to see, in the previous video we saw like what is Bayesian network and how the process is being evolved and etc. This video we will see like what is the actual semantics of Bayesian network is and how it is being involved. So what is the semantics of Bayesian networks? An entry in joint distribution is the probability of conjunction of particular assignment to each variable. Okay, particularly if you are assigning the values, it is called as the semantics of Bayesian networks. This you will be getting the values from the parent node of each and every process that you are actually being executed. Okay, that you will be calculating with a formula called summation. And this is the method of how you will be constructing the Bayesian network. You have to rewrite the joint distribution. Next you have to repeat the process and reducing each conjunction probability to a conditional probability and a smaller conjunctions. Okay, from that summation value you will be getting the values, but when you get a summation value you will not understand it, right? So basing that based on that, and you want to apply the product rule for each and every process that is being evolved, and you will be getting, say for example, probability of x of I slash x of I minus 1, and it continues equal to probability of x of I slash parent of x of I. That is, you are getting the value from the parent nodes, right? So this is how you will be getting the values. Example, in this it has been given as probability of Mary calls, John calls slash alarm, earthquake and burglary. In this you will be actually getting the parent of this is alarm, right? You will be getting the values based on that. Now what is this compactness and node ordering? The compactness of Bayesian network is an example of general property of locally constructed systems. Okay, in a locally constructed systems, each subcomponent interacts directly with only a bounded number of other components regardless of the total number of components. Therefore, the correct order in which to add node is to add the root cause first, then the variable they influenced, and so on until we reach the leaves. Suppose we decide to add the nodes in the order Mary calls, John calls, alarm, burglary and earthquake. Adding Mary calls, we don't need any kind of parents. Adding John calls, if Mary calls, the probability means the alarm has gone off, which of course would make it more likely than John calls. Therefore, John calls needs Mary calls as a parent. Adding alarm and adding burglary, in this clearly if both call, it is more likely that alarm has gone off, that if just one or neither call, so we need both John calls and Mary calls as parents. If next is adding burglary, if we know that the alarm state, then the call from John or Mary might be given information about our phone ringing or doing something else. So how we will be doing it is probability of burglary or alarm slash alarm, comma, John calls, Mary calls is equals to burglary slash alarm, since alarm is the parent node. Now when we add an earthquake for it, if the alarm is on, it is mostly likely that there has been an earthquake, but if we know that there are burglary, that explains the alarm, and the probability of earthquake would be only slightly above normal. Okay, so this is how the process is being conducted. So the conditions independence relations in Bayesian networks is a node is conditionally independent on all other nodes in the networks, as I have already told you. From parent, each child node is conditionally independent, and this is given as the Markov blanket. Okay, so this is how you will be determining the different kinds of process, and how the process of the Bayesian network is being evolved, and how the parent nodes and the child node is one-to-one correlated, and how the process is executed in this Bayesian network. Okay, so in this the actual conclusion is how we have seen is every node will be having the correlation, but it is not independent based on any of the process. Okay, in this you have alarm, you have burglary, you have earthquake, you have John, you have Mary, everything, but each one is independent of each of the node. See, in this diagram they have been explained it correctly. in node x of I is conditionally independent of its non-descendants, that is, given its parent is independent of every node. In the B part, a node x is conditionally independent of all other nodes in a network given that Markov blanket, that is, it is connected using a Markov blanket. So in this video I have taught you what is Bayesian network, the Bayesian network's continuation and how it is being involved based on it. So in the next video we will be meeting out with some other different topics and how the process is being involved. As of now, thank you.